Now let's consider, say, the nitrogen molecule. Two nitrogen atoms bonded together. That's the major component of air. So nitrogen is on row 2 of the periodic table. So now the atomic orbitals on nitrogen are 1s, 2s, and the 3 2p orbitals. So you have the 1, 0, minus 1 for m sub L values. So each nitrogen comes with all of these orbitals, and so if we draw them on an energy scale, I'll put the 1s down here at the bottom, and say the 2s here, that's higher in energy, and the 2p's, so we have 3 2p orbitals. So this is for nitrogen A, this would be for nitrogen B in the nitrogen molecule, and it turns out that when we add orbitals, only orbitals of the same or very close to the same energies have any significant overlap. So when we add orbitals, the 1s orbitals overlap strongly, but the 1s doesn't overlap strongly with the 2s, and so we neglect that overlap. I made a mistake here, that's supposed to be 2s. So when I overlap the 1s orbitals, I'll get a bonding and an anti-bonding orbital. So I'll just draw little lines from the atomic orbitals. When I overlap the 2s orbitals, I will get a bonding and an anti-bonding formed from the atomic orbitals. And then when I overlap the 2p's, since there are 6 total 2p orbitals, 3 from each atom, I'm going to get 6 total possible ways I can have them overlap. So I will get 2 of the same energy, one slightly different for bonding, and I will get 2 of the same energy and one a little higher in energy for the anti-bonding. So you can always see that the bonding orbitals drop in energy, and the anti-bonding orbitals always are raised in energy relative to their starting points. Okay, now I'm going to fit electrons in them. So nitrogen has 7 total electrons for each atom, so that's 14 total electrons. So I just start adding them from the lowest energy to the highest energy, just like I would in an atom. So that's the first 8. Now, when I have 2 orbitals of the same energy, I add them unpaired. I only pair them when necessary. So that gives me 10 electrons, so I have to get to 14. So this is 11, 12, 13, 14. So that's all 14 electrons. Now let's add up how many bonding electrons and anti-bonding electrons we have. So there's 2 bonding here, 2 anti-bonding in the 1s, so they cancel. I have 2 bonding in the 2s, 2 anti-bonding from the 2s, they cancel. From the 2p orbitals, I have 3 bonding orbitals, or 6 total bonding electrons. So there aren't any anti-bonding electrons to cancel the 3 2p bonding orbitals. So nitrogen is net bonding. Now I can find what's called the bond order. This is just 1/2 of the bonding electrons minus the anti-bonding electrons. So for nitrogen, I have a total of 10 electrons in bonding orbitals, and I have a total of 4 electrons in anti-bonding orbitals. So that's 6 divided by 2, or 3. So the bond order is 3. So that means I have 3 bonds between nitrogen atoms. And if I drew the Lewis dot structure, I would also get that same result. Nitrogen is held together by a triple bond.